In this lecture, we're going to look at the nomenclature of compounds that have more than one functional group. Specifically, we're going to address compounds that have an alcohol, amine, ketone, or aldehyde functional group. Now that we have several different types of functional groups, we have to come up with a way to prioritize them, and some of them are going to have higher priorities than others. So for example, anything that has a carbon-oxygen double bond is going to have a higher priority than anything that doesn't. So ketones and aldehydes will have higher priority than alcohols, which will have higher priority than amines, which will have higher priority than our alkenes and our alkynes. I have several tips listed here, and if you learn these strategies, this is much easier than having to go through and memorize a whole table. So for example, we already know that when there's a tie between a double bond and a triple bond, the double bond gets priority. And that's because the alkene comes alphabetically before the alkyne. We also have already observed that alkenes and alkynes are typically suffixes. So that means that they're always going to change the root name to an ene or an ine. Okay, here's another new tip that you want to make sure you keep in mind, is that if we have increased bonds to O, we have increased priority. So 2 bonds to an O, meaning a ketone or an aldehyde, has more priority over 1 bond to an O. Also, we want to keep in mind that oxygen has priority over nitrogen, and H has priority over R. That means that aldehydes with an H are going to have a higher priority than a ketone, which has 2 R groups. Here's a table that helps you to keep everything straight. Also, what we have in this table is we have some of the prefixes that we need to know. For example, if we have a ketone and an alcohol, the ketone is a suffix-changing functional group, and the alcohol, which is lower priority because it only has 1 bond to an O, becomes a hydroxy group. Alternatively, if we have an aldehyde and a ketone, the suffix becomes an -al, and the ketone becomes a prefix of oxo. We're going to go through several examples of this, but the ones you want to keep in mind for now are the prefix for the ketone, oxo, the prefix for the alcohol, hydroxy, and the prefix for the amine, amino. Let's look at our first example here. This one's fairly straightforward. In this case, we have an alcohol and an alkene. We want a number from the right, 1, 2, 3, to give the alcohol the lowest priority. If we number from the left, 1, 2, 3, 4, the alcohol will get a higher number. In this case, the alcohol has priority over the alkene. So we don't care about the alkene. We're numbering to give the alcohol the lowest possible number. Okay, so we get the alkene at 5. That's why we have a 5-ene. The alcohol we already talked about, that's a 3, and we have a 6-carbon chain. So that makes it a hex-ene-all because it has both an alkene and an alcohol. Let's quickly address the stereochemistry. The oxygen is a priority 1. The left is priority 2. The right is priority 3. And the hydrogen is 4. The lowest priority group is in the back, so we can ignore it. We go 1, 2, 3, and that gives us S. In this example, we have an alcohol, and we have amine groups. The alcohol has priority over the amines, so this becomes a cyclohexanol because of the alcohol. The amines then are turned into prefixes, and we have a 3,4-diamino, and then the chlorines become 2,2-dichloro. When we're doing the numbering, keep in mind the alcohol has to have the 1, and we don't have to put that in our name here because it's cyclic. So it's assumed the alcohol has to have the 1, and then we number to give everything else lower numbers. So that's why we're numbering clockwise. Here's another example. In this case, we are again numbering to give alcohol priority. If we number from the right, it gets a 2. If we number from the left, we don't get an alcohol until 1, 2, 3, 4, 5, 6. So we want a number to give that alcohol the lowest possible number. In this case, we have 2 alkenes, one at 4 and one at 6. So that's where we get the hepta 4, 6 diene from. The all comes from the alcohol. In this example, the amine is the priority group. It has priority over the alkyne. So we number to give the amine the lowest priority. That means from the left, because if we numbered from the right, we wouldn't get the amine until 1, 2, 3, 4. So we have the amine here at 3. The ine or triple bond starts at 5. And then we also have some stereochemistry. The lowest priority group is in the back. So if you were assigning stereochemistry, you'd give a 1 to the nitrogen, a 2 to this carbon on the right, a 3 to the carbon on the left, and we go 1 to 2 to 3. That's our R. In this example, we have both a ketone and an aldehyde. The aldehyde has higher priority. Remember that we said that anything bonded to an H has priority over something bonded to an R. So the aldehyde gets the 1. That's why we have the al over here. And that's also why we start numbering at that aldehyde. That means our ketone here at position 3 turns into an oxo group. So we have a 3-oxohexanal. In this example, we have an aldehyde, which takes priority and becomes 1. That means that our hydroxy group here is at position 3. And typically, alcohols are suffixes, but in this case, the aldehyde has higher priority, so it turns into a prefix. This is a fun example because we get to use parentheses. We have a 6-membered ring here, which becomes our parent chain. If we number starting at the ketone, that puts our substituent at position 2. So that becomes the part that we put in parentheses. You'll notice that with this piece, it doesn't matter where the ketone is. We have to number from the point of attachment to the ring. So this whole piece then becomes a 3-oxopentyl group. And it is attached to the cyclohexanone at position 2. In this last example, we have both an alcohol and amine. The alcohol has higher priority, so that turns the amine into a prefix. That means we need to number from the left. And the alcohol is on position 2 here. The amine is on position 5. And the alkene is on position 3 over here. Notice that we did have to include the stereochemistry. The hydrogens are on opposite sides, so that gives us E stereochemistry. And if we were to assign priorities around carbon 2, we'd get a 1 for the alcohol, a 2 on the right, a 3 on the left. Our lowest priority group is in the back. 1 to 2 to 3 makes R. That concludes this lecture on nomenclature of alcohols, amines, ketones, and aldehydes. Please review the study guide and let me know if you have any questions about any of the content.